Okay, so cloud Okay, so cloud computing, fog computing, and edge computing can be presented in a network as this shown in this figure. These computing methods basically differ based on the location where we do the data processing. So cloud computing is done uh, at the cloud service. So I will share the OTP. Actually, you need to uh, take it. I mean, I can't keep adding every time a new person ending. You can take down uh, by asking another person in the meeting. Okay, so this is the OTP code. If possible, please take it down. If you have lost it, then ask from another person who is in the meeting. So the methods of computing, as I mentioned, can be of three different types. So we can have cloud computing, we can have fog computing, we can have edge computing. These methods differ by the location where the processing happens. So the cloud computing is done in a centralized location, and it is done in a cloud server, basically. So the cloud servers are available in data centers. Those data centers are located in specific regions in the world. So those centers are having multiple cloud servers, which have like okay, so have a high processing ability. However, the location of the cloud servers are in a specific region in the world. Then we can have fog computing, which is done in an intermediate location from for example, from network and the cloud computing location. Then we have edge computing, which is done at the edge of the network. So edge of the network is defined as the boundary which separates the local network and the internet. Okay, so there's like once we have a local area network, that local area network is connecting to the public internet via an access point. It could be a router, it could be the base station. So through those access points, the local area networks connect to the public internet. So the boundary which defines the local area network that connects to the internet is called as a network edge. So at the edge of the network, we can have a server which is connected to the access point, and that server can do computations. So edge computing means the computation done at the edge server. So basically, those are the three types of computing methods. Then we have the cloud computing. So the cloud computing is done at a data center which is available in a certain region in the world. So the cloud servers are inside data centers that are having a large number of supercomputers stored in them. So these servers or these supercomputers, as I said, so server is like a computer which has a very high processing capability. So a server, in the server we can install multiple virtual machines that can do different applications, that can run different applications, and we can install different softwares in the virtual machines, and we can do network functions. So any other applications we can run in those virtual machines. So therefore the flexibility of the using those cloud servers is very high. So we can flexibly put in softwares or remove softwares. We can update softwares. So if a server is not working, we can back up the uh, storage that we lost to another device and so on. The ability to recover data, the ability to secure the data, and the ability to manage the network functions or any other application services is high with these cloud computing technologies. So today we are going to talk about cloud computing, fog computing, and edge computing. So also, since the module is Internet of Things, we are going to focus on how we can relate these computing methods to IoT applications, and how we can combine these technologies to improve the IoT applications. So we'll be talking first about the cloud computing technology. Right. Um, so the cloud computing is something we have discussed in previous lectures also. So we have talked about IoT systems which use cloud computing approach to do the data storage and analysis. So today, we are going to be discussing again that scenarios where we have sensor nodes connecting to an access point. Each could be a router or a base station. So this base station or router will connect to a set of routers and switches which comprise the public internet. Right. So the cloud server will be located at a location which is far away from the access point. Let's assume the cloud server is connected to this router. Cloud server is able to do the data computation, data analysis. Right. So it is able to do computationally difficult tasks. Right. So under data analysis, computationally difficult tasks will be done. Also we can do like machine learning and prediction of certain outcomes. Right, so machine learning based predictions can be made. Next, we can we require data storage. So cloud computing allow us to store large volumes of data. So in IoT networks, we have large volumes of. So we require like specific storage space to store these large volumes of data. So our own devices cannot, store large amounts of data. So we require some separate servers to store the information. Another application of the cloud computing is remote monitoring. So since we are storing our data in a cloud server, which is connected to the internet, we can, as a customer or a manager of the IoT network, we can access that network through our devices, which are connected to the internet. So the customer or the manager of a IoT network can easily monitor the IoT environment by connecting to the internet, and also gather the information through the cloud server. So we have the option of doing remote monitoring. So basically those are the like applications, main applications of cloud computing. There are other applications also like data security, like providing data security and privacy. So those are the basic aspects of cloud computing, right? So if we do not have cloud computing methods, what is going to happen? Right? If we do not have cloud computing facilities, then what kind of situation we will have? Right? The sensor nodes will collect the data, and they will send all the data across the internet to the customer directly, right? Or the customer or the manager. So the customer or the manager will get the data to their devices, right? So let's assume the customer is having is having a device, and the device is connecting to the internet. Right, so the total data will come to the customer. So there's a high volume of data, and the customer requires specific hardware and software to analyze uh, the data. Right. So, for example, if the customer uh, read emails using cloud services, then the customer has to have the specific hardware applications installed in his devices to read the emails or read the messages he's receiving. There's a lot of code involved directly, the data from the access points, I mean, in the network. And also, since the large amount of data are sent, the computationally high tasks has to be done, right? High computationally cost task has to be done by the customer. So, so the customer has to spend a lot to cover those, requirements, right? And the storage require high storage capacity, right? So this is something available. These conditions are occurring when there's no cloud computing facility. Also, when data is lost, data recovery is going to be difficult because only your device will have that data. Also, providing data security and privacy, it's going to be a challenge. You have to provide it on your own, so it's going to be a challenge. So this is the situation that occurs if we do not have cloud computing. Right, you can let me know if you have any questions. So from that, we actually understood that cloud computing has many advantages, right? So the applications of or the advantages of cloud computing are numerous, and we will consider like some of them. So one thing is that we can easily manage our data management, data storage, data analysis, remote monitoring, then cost reduction, scalability. The word scalability means like we can add many devices as required. So although we add a lot of devices, the cloud servers are able to manage the large that is received from the multiple number of devices. Then we also have reliability in the data communication and data security, and right, so data processing is done by very highly computational devices, so data processing ability is very high. Data recovery options are available. Data security options are also available by the cloud providers. Data storage options are also available. So due to these multiple reasons, currently cloud computing is popular technology which is used for different applications, and specifically IoT applications also require cloud computing technology. So once we take, for example, AWS IoT, which is conducted by the Amazon Web Services, allows us to connect multiple IoT devices into the AWS IoT platform. So they have their platform, and we can connect through internet to this IoT, their cloud platform. Okay, so we can connect our device cloud platform, and we can connect as many devices as we require for our certain application, right? So depending on our application, it could be a commercial application or a personal application. So we can connect our IoT devices to this platform. So we have our IoT devices with our embedded systems. So we can connect our embedded hardware to this IoT platform, right? So if we customize a certain device based on our own requirement, we can connect the embedded system containing the sensors, the controllers, microcontrollers, and the communication modules, which comprise the embedded system, can be connected to this cloud platform. So we need to first configure our device in the platform, and then we can, after we have configured and we have connected our device initially to the platform, then we can start transmitting the data. So the data will be uploaded to the cloud platform. So after that, we can actually do data analysis and do any kind of prediction about the future. So likewise, there are third parties which are providing cloud computing services in the present. So earlier in the class, we learned about three types of services that cloud computing provides. Can you name all these three types of service models?
Software as a service, platform as a service, infrastructure as a service. SaaS, PaaS,
Yeah,
and
so yes. Yeah. So yeah, that's good. So we'll be talking about those three types of key service models. Software as a service, okay, so in these three types of services, key service models, we have two parties, like our own device and the cloud provider. So we have our own device and the cloud service provider. So the cloud provider will provide some like services to us based on the service model. So if we take the first model, software as a service, in there, what happens? Right. So does the clouds do we need to install softwares, or do we need to have a specific hardware to access this service? Right. So do you know any example for software as a service?
Email services.
Yeah, Gmail. We can say, yeah, email services. So one example is Gmail. So any service that we can, any software that we can access through the internet without installing any specific like any softwares in our own device in an offline manner, we can call as software as a service software. I mean, software under software as a service. So we can take, for example, Google Workspace, Google Docs. There are other various Google applications as well, as you are aware, right? So Google Docs, Google Sheets, and other types of softwares you can use without installing any software in your own computer. Need a tool in your own computer to access this software. So in this software, you can write reports and letters as usual in the Microsoft Word. Just like Microsoft Word, this works on its own in the internet. So it is run in a certain cloud server. Then we also have Dropbox, where we can store our documents. So that is another example of the SaaS softwares. There are other types of many, examples for such SaaS applications. So they are coming under different names. So we can consider these basically as the examples of SaaS applications. And in there, we use the application data operating system middleware services. That means the services which are used by the cloud servers to interact with different applications and give the service that is requested by the customer. So the cloud server is providing us with the application, the data, the operating system, middleware services under SaaS. Right? So then have the networking functions, virtualization functions, and storage functions done at the cloud server. The cloud provides us these services based on the requirement. So once we are requesting a service from this cloud server, this cloud provider provide the networking facilities and virtualization facilities and storage facilities. So I talked about the virtualization function in our last classes. So basically, virtualization means that we can install software in servers and we can run those softwares to get certain work done. So if it is a networking function, we can install networking functions as software programs. And if it is the application, we can install that as a software program. So we can install those functions or applications inside something called the virtual machines. So virtual machines are kind of a computer which is also created by software programs. Virtual machines have the ability to do the same functions as a computer, and it has a certain operating system, and it has the we can install applications inside the virtual machines. We can install applications as we normally do in a certain computer. There can be multiple virtual machines in a single server. So there can be multiple virtual machines. So therefore, a server is called different virtual machines. Each virtual machine is able to do one specific application. I mean, if required, it can do like an application like managing the emails. Another virtual machine can manage me, like YouTube video streaming, right? So depending on the application that is by the customer or the company, certain virtual machine can do one application. Virtual machine can be allocated another application. And otherwise, we can, in a single server, we can do multiple applications. So the cloud provider has multiple servers like this. So the centers are consisting of multiple number of servers like this in the data center. So therefore, I agree that the data center is to manage a lot of applications at the same time. So there are a lot of customers who are accessing the data center. The data center has enough resources to run the application simultaneously and give services to multiple users at the same time. So all these servers have virtual machines and there are multiple virtual machines inside them. So likewise, the cloud provider is able to provide us the networking functions, virtualization functions, and storage facilities. So that is basically regarding the software as a service model. Then we will talk about the platform as a service. In platform as a service, we have control our device or our company has a control over application and data components. Application and data components. We have the ability to control these two items. However, the cloud server will host these applications. We'll just have the control this application and data data components. So this is basically used by developers. So developers create applications on their own requirement, and use the rest of the resources in the cloud server to operate this application. So web developers and data managers, we can say, use this application and data like platforms provided this cloud server to build applications and data management applications in the cloud server, right? So in the cloud, they are building application and the data input methods, data input and data management methods, they are designing or developing. They are building it on top of the cloud server resource, right? They are building it on top of the resources that are provided by the cloud server. So the cloud server is providing other things: operating system, middleware, networking, virtualization, storage. So these services are provided by cloud server. The development of applications and management of data is basically done by the web developers and those related employees. So they are able to develop the applications in the way they. So basically these three functions, basically these networking, virtualization, storage functions are fundamentally provided by the fundamental services provided by the cloud. So all the time these three services are provided by the cloud. So other services can change based on the service model that we are selecting or that we have selected. So next we are talking about the infrastructure as a service. So infrastructure as a service means we have the control over almost all the functions of the almost all functions of the at the cloud server, right? Apart from the networking, virtualization, and storage, we are taking control over the application, data, operating system, and middleware. So we can change them as our need, and we can services to our customers on the infrastructure that we have created. Right, so this is especially used by big companies or startup companies who want to build a very unique infrastructure and provides a very separate services, and so they are doing it through the cloud servers. So they are building that their company's infrastructure on the cloud servers. So we can take, for example, Amazon Web Services, AWS. It is a infrastructure as a service. So it is using infrastructure as a service model. It is using the cloud servers and it is building its application data data and management methods, its own operating system and middleware services. So AWS is defining those elements on their own by their own developers. So then after that, therefore they have the control over these components. So the cloud provider is only hosting these applications and providing the storage for these elements. So basically, there are different companies who are using this IaaS like service. So we can take AWS, Microsoft Azure, and Google Compute Engine. It is known as like that. So anyway, the companies like AWS, Microsoft, Google use IaaS as one of the methods of delivering their services. So they use that service to deliver their service. So basically, those are the three types of service models of cloud computing. For platform as a service, we did not discuss about the applications. In there, we have applications that are provided by AWS. AWS, there are different names for these kind of platforms that allow us to develop applications on top of those platforms. So AWS Beanstalk, you don't have to remember these things. It's just that it is just to show that these things exist. So AWS Beanstalk, some application platforms are available by Cisco as well, as I remember, and then Google App Engine. So likewise, there are examples of these services being used by real companies. Next, we are going to be talking about the three different types of, other types of computing. So I'm going to erase this. So after cloud computing, I mentioned about fog computing and edge computing. So basically, these three methods vary by the location where the data processing happens. Right. So data processing location is different in these three types. That is the difference between these approaches. Data processing location differ by data processing location. Since we talked about the cloud computing, now we will talk about the fog computing and edge computing. Right, so fog computing another thing is we can use all these methods for IoT applications. So based on the IoT application that we require, that we want to implement, we can select what computing method we are going to use. So fog computing method also can be used for IoT applications if required. So basically, I will first explain what fog computing method is. Right, so do you know what fog computing is? I already mentioned, I think. So in fog computing, now IoT application or IoT sensor nodes. Let's assume we have like multiple, like a large number of sensor nodes which are connected to a certain access point. So in that situation, we are like uploading large volumes of data, and so let's assume our cloud server is somewhere at a data center in US. So let's assume, so this is in Sri Lanka, this is in US. The cloud server is in US. So in that case, the data latency of the data transmission is going to be high, right? In that case, like once we are sending our data through the internet, right? The internet that connect our data to the cloud server is also very huge network. It is a massive network. Therefore, like sometimes there could be considerable delays for our data to reach the cloud servers. So there are intermediate servers which we can, initially configure to use as servers to process our data, right? So there could be some servers in intermediate locations between the cloud server and the access point, which can do the computationally costly task. Right, so some companies or some organizations which are connected to a certain router in the public internet can provide us the service of computing our data and processing our data and giving us a certain update. So this kind of computing happening in an intermediate location between access point and the cloud server is known as the fog computing. So the fog computing is done at fog servers. So sometimes it is used instead of cloud servers, where we require the data to be processed very fast, and we require the data to be, updated, and we require a certain feedback from the servers. Right, so fog servers can sometimes do the tasks that are done at the cloud server. So instead of cloud server, we can use the fog server in some applications. And access point. So then I hope it is clear to you. Now we will next talk about the edge computing. Edge computing is done at the access point. So access point could be a base station or a router, as I said. So the base station, if we take, for example, can have a certain control unit. Right? So the base station, near the base station, we will have a certain control unit to control the access of the data. Access of users to the network. So the control unit can have certain computational power. So if we install a server or the edge server into this, we call this edge server. If we install an edge server into this control unit, we can do the computation at the access point itself. So the computation done at the access point, right? So the computation done here we call as edge computing. So in situations where we require very high efficiency and very low latency, we sometimes can do the computation at the edge server and get the information back within very matter of very small number of seconds, like within 1 millisecond or below 1 millisecond, we can get some update back from the server regarding the IoT environment or regarding the condition of the environment, for example. So we will take, for example, like situations where we need to monitor the traffic, vehicle traffic monitoring, or else air quality monitoring. So applications, we can get real-time updates using this edge computing method, right? So we can get real-time updates with low latency. But once we have edge computing technology, and so that is we require instant feedback. However, some disadvantages also can be there. So edge server might not be efficient as the cloud server. point, we cannot install high number of computational, servers. So may not be capable of doing very high computationally costly tasks. So in that case, the data has to be sent either to the fog server or the cloud server to do the required processing of the data. However, once we only need just a very small amount of computation done, or a very low level of computation done, then we can use edge computing. Right? I hope it is clear. So, so basically, edge server might not be computationally efficient all times. However, edge computing is also a good method for different applications which require very low latency of about below 1 millisecond. And once we have large amounts of data, right? So once we have large volumes of data, we might not be able to send all the data to the cloud server. Rather than sending all the data, we can process the data in the edge server. We can make some important decisions, right? We send a certain batch of data or not. And after deciding that, we can send only the useful data to the cloud server. Right, that option is also there. I think that's very important. So once you are doing projects also, you can consider that. Right, we can do edge computing and send only the useful data to the servers, to the rest of the servers. So send only useful data to the cloud or fog servers. So likewise, we can improve the computation and the networking using this edge computing approach. So if you have any questions up to that point, please let me know. So apart from that, once we consider about the 5G IoT, 5G based IoT networks, we need to meet criteria such as we need to maintain low latency. So if we have 5G based IoT network, we need to deliver services with low latency of about 1 millisecond or less. And we need to have lesser error in the data transmission. So the error rate also must be kept at a minimum. Error rate must be about 10 to the minus 5 or below range. The data rate, peak data rates must be above 200 gig per second. Anyway, the data rates must be at least I think 10 or 20 gigabits per second download, and 10 gigabits per second for upload. So once we have this much of requirements of upload speeds and download speeds, we need to quickly get our data uploaded into the system, right? So large volumes of data need to be uploaded into the net. So if we have computing, then we can actually do some process. We can do the rest of the computing for computing, and then we can provide feedback to the customers required. And also latency be minimized heavily because the the network and not at the server. So the latency of data traveling along the public internet to the cloud server will be minimum. So the public internet is also very wide network. Through that network, until the cloud server is also going to consume latency, and therefore it is not sometimes the optimal solution for providing services with low latency. So therefore, especially in 5G based IoT applications, we need to consider about the latency, about the error rate, and the peak data rates of the transmission. So basically, those are the aspects I wanted to discuss. So apart from that, as I said, uh, hybrid computing means we can have two or more combinations of computing approaches for a certain scenario. Okay, so hybrid computing means like you can use two or more methods of computing. More methods of computing. So we can combine edge computing and cloud computing, or else we can combine edge and fog. We can have cloud and fog. Likewise, we can have hybrid computation methods to solve some problems. So basically, that is regarding the cloud computing section for the IoT. So next, so if you have any questions, you can let me know. So in the interactive class in this week, I have given the students a small tutorial. So that is the tutorial that I will be discussing today with you as well. So this tutorial question is designed for you to get prepared for assignments and the end exams. So you can try these like tutorial questions, and you can get prepared for these questions, just not because of exams, but also in order to improve your own like logical thinking about the cloud computing approaches. Right, so if you have any questions, you can ask. I will also discuss these questions while I'm writing the question. So I will be writing the question. If you want, you can take it down. Right, so assume that you are an IoT engineer, right, at a vehicle like managing company, right? So let's assume that company is like Pick Me or Uber or something like that. So these vehicles are equipped with IoT sensors. So that's where the IoT comes. So vehicles are equipped with IoT sensors. So IoT sensors could be used for different applications. So some of the applications are like location tracking. Location tracking. fuel monitoring, fuel consumption monitoring, etc. There could be other applications. So the goal is to provide IoT and cloud or computing technologies, is to propose potential IoT and computing technologies for the applications, right? So you can select one application and you can provide like you can design the most suitable cloud computing or other type of computing method that should be used for the application. So first you need to choose the application, choose the specific application that that will require computing capabilities. So some examples of the applications are location tracking, fuel efficiency monitoring, and predictive maintenance. So with vehicles, we need to maintain the vehicle, right? So after time, we need to have a maintenance. So therefore, we can predict the time at which this maintenance should happen. So maintenance means like predict the exact time that vehicle needs to be maintained. So clearly define the objectives and the requirements of the selected application. Right, so you need to define the objectives and the requirements. So objectives means like what are the things that you are going to achieve in that application. So if we take location tracking, the objective is to track the location of the vehicle with minimum error. So you can define that as an objective. And then requirements of the selected application means like what are the hardware and software that is required for the application. So for location tracking, you will need some hardware, right? You might need some sensors like GPS sensor or other tracking sensor. And then you will need some software that can read the data, this GPS measurement, right? Likewise, you need to mention the hardware and software that you require for this specific application. Then we have to, in this software requirement, you can also make whether we require edge server, fog server, or a cloud server. I'm going to erase this. Then we have the second question, evaluate the possibility of using edge, fog, and cloud computing. So you need to consider the possibility of using edge, fog, and cloud computing for the selected application. You need to discuss the advantages and disadvantages of each type of computing. Next, you have to establish a selection criteria to get the best computing approach. So in here, consider factors. Right? So you need like create a selection criteria to select the best the application that you have selected. So based on application, you need to create the criteria, right? So for example, if you are proposing the location tracking application, then selection criteria like you need to define the criteria that allow you to best computing approach. So once you are defined criteria, you need to consider data processing, storage, real-time update, real-time facility, network connectivity. Data privacy, cost of the implementation, and resource availability. Etc. So you can consider these kind of factors to define the best method to do in your application. So if you take if you application which requires high, then it should be one of the area. And then it is also another selection criteria. If it requires real-time updates, it's also one requirement. then if you require high network connectivity, it means like the ability to connect reliably to the network. So if, for example, if you are connecting multiple devices, whether the computing technology can handle the large amounts of data that is introduced because of the massive connections, and also is the infrastructure reliable, right? So can we connect our data to the cloud servers? Will there be some network failures? And if there is a network failure, will this application get affected by that? Right? So those factors, right? What happens if the network fails? And are there any solutions to this application? And so on. Then data privacy, data security, right? Data security and privacy. Then cost of the implementation, and resource availability, and so on. So these factors you can consider and you can define for your system. What are the basic factors you require and what are the factors you don't require. You need to choose the best computing method, choose the most appropriate computing solution. For the application. And also, so you have to do that based on the evaluation and criteria you have defined in question number 2 and 3. Also, in that same question, you need to give the reasons. Give reasons why your computing solution, why it aligns with the objectives and the requirements that you have defined in question number 1. So in question number 1, you have defined objectives and requirements for your system. So you need to you need to justify why the cloud computing method you have selected matches with the or satisfy the objectives and the requirements. And finally, you need to draw a diagram of the overall view of the IoT system with all relevant components. So label each component clearly. Right. So basically, that is the question that you have to address. So this is actually about a vehicle vehicle monitoring IoT system. So based on the requirements of that IoT system, you need to select the computing method that you will be using. So I will erase this. So you have set of vehicles that are connected to, could be different types of vehicles. So there are like bicycles, cars. So you have sensors in each of these vehicles. So those sensors will be connected to the network. So the data that you collect will be either processed at the edge of the network, or it will be processed at the intermediate location of the internet, or it will be processed at the cloud server, where it is where the cloud server can monitor the environment. So once you are drawing the diagram, you can include the servers that you want in your system, and you can include what are the computing methods you need in your application. So depending on application, you need to decide the computing method, and you need to label each of the components, the basic components, such as the sensor nodes, the access point, yes. With the diagram, you can give all the information about your system. So that's basically regarding the tutorial question, right? So apart from that, so do you have any questions regarding this tutorial? As I mentioned about AWS IoT, I will also mention that there are free courses that you can follow in AWS IoT. So some courses are freely available. You can follow them and get certificates. So the AWS IoT has its own architecture. So and a guide regarding that I have included in the LMS. You can refer that in the resources section, right? In the very top part of the module page, you can see this PDF. So you can refer that document as well. So basically, AWS IoT is defined specifically for IoT applications. So you can connect your devices, IoT devices, to this platform, and you can get some important data from this infrastructure. However, it will cost you. You might have to pay for the. However, in order to understand the architecture, you can follow these courses and you can learn about the IoT, AWS IoT architecture. So AWS has its own standards and policies, and also some definitions that they define for the architecture. So they have different architecture, so that they use to do the computation and the networking of the data. So you can refer those courses and follow those. You can get the certificate if you have the. I have for these courses in the so you can refer those, get more information. So that is basically for today's class. If you want more details, you can let me know. So do you have any questions? So if you have any questions, you can let me know. And about the project, if you have any questions, then that also you can either email me or call me via WhatsApp. So my number is there in the WhatsApp group chat, so you can contact me like that. So in the future classes, we will be covering content related to security and data analysis and about communication protocols. So I will talk about security, IoT security, and the communication protocol that are used by IoT systems. Such as SPI, UART, I2C, UART, and so on. So these are the things I'm planning to do in the next class. So in today's class, I will summarize what we have done today's class. We have discussed about the ethics of computing technologies, cloud computing, which happens at the cloud server, the fog computing, which happens at the intermediate server between the access point cloud. So the three main computing approaches. So once we take about cloud computing approaches, so cloud computing stages, when we compare with no cloud computing scenario, ability, like, reliability, scalability, reduced cost, have the data processing ability, data security, and so on. So cloud computing gives us a lot of applications, a lot of advantages. And then we have three types of service models in cloud computing. The three types of software as a service and platform as a service. We talked about these three methods and how we can control the application or the operating system in the infrastructure as a service. So in the infrastructure as a service, we can control all the elements like application, operating system, data, middleware, and so on. In platform as a service, we can only control application and data. The rest of the elements will be controlled by the cloud provider. In software as a service, we do not have any control over the software. That all things will be controlled and hosted by the cloud provider. However, we can use those softwares and get our own requirements satisfied. So the examples of this is Google Drive, Google Docs, Gmail, Dropbox, and so on. Then we have platform as a service where we can build a platform, we can build our applications in that platform. So AWS Beanstalk is one example. And then infrastructure as a service, we can take AWS as one platform which uses infrastructure as a service, and Microsoft Azure and Google Compute Engines. So in here, Google App Engine is one platform as a service. So these are the three basic service models in cloud computing. So those are the content we have in today's class. So I think I will end today's class now, if it is okay with you. If you have any questions, please forward to me via email or via WhatsApp. You can let me know. So thank you for attending today's class. I hope you understood the content. If you did not understand, please let me know. Okay. I hope you marked your attendance. So I think with that, I will end today's class. Okay, since there are no questions, I will end today's class. So thank you for your attendance. I will end the class.